Hello everyone, welcome back to the programming of 8085 microprocessor. So the first program that we are going to talk about here is a program to find the 2's complement of a number which is stored from memory location 3330 and there are 5 numbers. So you have to take the 2's complement of each of these 5 numbers and store them from memory location 4100. So the instruction that comes like this means what you have to first point to the memory location 3330 and BC pair of register will contain 4100 and then whatever is the length of the block means there are 5 data bytes which we have stored in D register, and then whatever is there in memory take it to accumulator. Why are we taking it to accumulator? Because we want to complement that data, that is 1's complement, add 1 to it, that becomes 2's complement. So that is complement accumulator and increment A. You can replace this increment A by add immediate 0 1 also. After that you have to put this data in memory location 4100. That address is there in BC pair of register. So the instruction that we can use is STX-B. Once you store that first data as 2's complement in 4100, now you have to go to 3331 as well as 4101. So for that we have done INXH and INXB. Okay, then you have to go back to do the shifting of the data, complement it, and then take add 1 to it. So that is the loop, isn't it? So the counter is D, so we are decrementing counter and then going back to take the data to accumulator, complement it, again add 1 to it, and then store it in the next memory location. So this loop goes on for 5 times, and after the D becomes 0, after the D register becomes 0, we are going to end the program. Yes, that is what is 2's complement of a set of numbers which are stored from one set of memory location and storing it in another set of memory location. Okay, the next instruction or next program is an 8-bit number is stored in memory location C1400H. You have to count how many zeros are there in the given number. For example, if you take the data as 80H, that is 80H. So what is the binary format of that? It is 1 with 3 zeros and again 4 zeros. That is 1 0 0 0 0 0 0 0. So how many zeros are there? There are 7 zeros. If you put the data as 80 in C400, then the result 07 should be there in C500. Okay. So for that, first point to the memory location, then take the data to B register and then take the counter C as 00 because that will take how many times the data how many times zeros are there in the given data, and then you have taken move immediate E with 08 because you need to rotate the whole set of numbers or whole set of data bits 8 times. So for that you have taken E with 08, that is the counter. Now whatever is there in D register you have taken to accumulator and then rotated it. You can rotate either to the right or to the left. How many times you are rotating? You are rotating 8 times. Once you rotate, if the carry is 0, then you are incrementing counter. If the carry is not 0, you are not incrementing. So that's what is. After rotation, whatever is there in accumulator, again shifted back to B register and then jump on carry to down and then increment C, then decrement E, jump on no 0 to loop, and then you are giving the result to accumulator, and from there you are shifting to C500. So this is how you shift the uh, or how you count the number of zeros in the given data byte. Okay. So the next program is write a program to fill up memory block of 20 memory locations starting from 2000H with byte 00 and FFH at every alternative memory locations. So when you are storing them in every alternative memory locations, you have half the locations with 00 and half the location with FFH. So for that we have done what? We have taken the counter in C register as 13H and D register with 00 and E register with FF. So what we are doing, whatever is there in D, we are moving to 2000, whatever is there in E, moving to 2001. So this we are repeating on alternate memory location. So first point to the first memory location, whatever is there in D, move it to memory location. Then we are decrementing C, and then we are incrementing HL where we are moving the contents of E to memory, and again we are incrementing, again we are decrementing C, and then going back to do the repetition. So here 100 is stored in one memory location, FFH is stored in next memory location, and then we have gone back. So when you see this, we are doing, if there are 20 data bytes, we are doing it for, the repetition is for 10 times. For that reason, we have put C with 13H. What is that? It is half of 20H in hexadecimal. Okay, so this, after when C becomes 0, it is the end of the program. Okay. Okay, now I want you to do this program output on your own. You have to trace this program and tell what is the aim of the program. These type of questions are asked in many of the exams for 5 marks. So you can see here I have given you 2 questions. One is LXIS 2500, MBI V01, MOV A M, CMA, add V, INXH, move MA, halt. So what is the meaning of this program that you need to write here? And there is another question on the same slide. MVI B00, LDA 201F, A901, jump on 002 down, move immediate B, EE, and then halt. You need to write what is the program doing here and what is the output. Okay, so please waiting for your reply. There is another program like this to trace out and write the purpose of the program. So when you are writing the purpose of the program, you have to consider this as an example, that if the input data at memory location C000 is 05H, means what? When you are taking out the out, or when you are tracing this program, let us consider that at C1000 we have data as 05. Considering that, what will be the meaning of this program? You need to tell us, and also what is the content of all memory locations in the program from C1001H till what? That also you need to understand here. Okay. There is another program for tracing out. This is another one where MBI C08, LXI 6000, move the contents of memory to accumulator, rotate it right, decrement C, go back, you are rotating it, and then incrementing the HL pair and storing that accumulated data into memory. So what is it doing? So that also you have to write. Okay. Next, there is with order byte stored in memory location 3000. Write a program that checks the given number is palindrome or not. If the number is palindrome, then register B should contain 00H, else it should contain FFH. Now, first of all, we need to understand what is a palindrome data. So, the palindrome data is something called as, if you divide it into 2 parts, the first half is the reflection of the second half, or the other way you can say, if you read even in one way or the other way, both way it should read the same. For example, 1 2 1 or 1 2 3 2 1 or 1 2 3 4 4 3 2 1. So all these are palindrome data. So here in the example what is given, it is a 4-byte number. So 4-byte number is what? 1 2 3 4 4 3 2 1. If this is the number which you store in 4 consecutive memory location, then B register should contain 00H. If the number is 1 2 3 2 4 3 2 1, so there is a non-palindromic. If you see here 1 2, it is not 3 4, it is 3 2 and then 4 3 2 1. So there is 2 which is not matching in the direction of 1 location, one part of the other way, so then it is like it is not a palindrome, so that time it has to be stored as FFH. Okay, so the program goes like this. You are going to point to the memory location D1000 with HL pair, point to the memory location D1003 with D pair of register, and then move immediate C with 02, and then move the contents of memory to accumulator, rotate the contents of accumulator right without carry, and then again do it for 4 times, and then exchange the contents of DE with HL. Once you exchange, then you compare the contents and then jump on no 0 to next location. That part we'll see what is next location. Again you exchange and then increment HL pair, decrement DE pair of register, decrement C and jump on no 0 to loop, that is again move the memory to accumulator. So this part we are repeating. If the comparison gives not equal result, then we are going to go to the end of the program, and that's it. Okay, so that is the end of the program. So if the content are palindrome, then B is taking 00. If not, then B is taking FFH. Okay, so that is what is the palindrome property of a number. Okay, with this we have come to the end of 8085 programming. Thank you.